How we hear the music notes. We heard comes in form of wave, in which term of notations it comes with frequency. But what is frequency? It's a repetition with time reference. We already know that frequency affects pitch. The higher it is, the higher pitch is sounds. Historians discovered that there were mathematicians in ancient times, both in Mesopotamia, India, China, and Greece. In the 600 BC period, they learned about the relationship of mathematics and music. A philosopher and mathematician called Pythagorean discovered that the sound you hear is melodic, or harmony caused by the same size of line, the same tensions. The length is relatively simpler number of fractions, such as 2 to 1, 3 to 2, 4 to 3, and etc. Harmony is a term of two sounds playing at the same times, producing sounds that humans can pleasantly hear, such as do and the high do. It's also known as the octave. The do and the high do are the first and the eighth notes in the scale respectively. Do and sols, also known as the fifth. Do and sols are the first and the fifth notes in the scale respectively. The octave and the fifth are considered the most harmonious to human ears. If we consider from what we stated earlier, the mathematical sequence that goes according to it is the Fibonacci numbers. The Fibonacci sequence plays a big part in Western harmony and musical scales. Here's are the facts. An octave on the piano consists of 13 notes. 8 are white keys and 5 are black keys. A scale is composed of 8 notes, of which the third and fifth notes create the foundation of a basic chord. In a scale, the dominant note is fifth note, which is also eighth note of all 13 notes that make up the octave. 8 divided by 13 equals 0.61538. It's the approximate golden ratio. Fibonacci doesn't only relate to notations only. Composer and instrument maker have been using Fibonacci sequence and the golden ratio for hundreds of years to compose and create music. For instance, Mozart based many of his work on golden ratio, especially his piano sonatas. Exposition, where the music theme is introduced. Development and recapitulation, where the theme is developed and repeated. Mozart arranged his piano sonatas so that the number of the bars in development and recapitulation divided by the number of the bars in the exposition would equal approximately 1.618, the golden ratio. This is a monochord. It uses to study about notation when we put weight at 1/2, 1/3, 1/4, and 1/5. We will get the notes follow this picture. We used 2/1 and 3/2 to make notation scale. Since we already know that having a note in frequency of 3/2 will provide a pleasant sound. If we calculate notes from scaling of 3/2, we probably will find more than one harmonious note. Pythagoras then create a scale as follows. From the point that every 2F, having F be the frequency of the notes is the same note. For instance, F, 2F, 4F, 8F would be the same note. When we convert it into scaling between F and 2F, then sort by its number, the result will be and frequency differences are whole, 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 half, whole, whole, half. Since every odd harmonic will provide a new sound, if we arrange them in terms of scale, we will get the natural scaling in music. And these are the notes: C, D,